over the quadratic squared, and then another like ex plus whatever letters I'm running on over that irreducible quadratic cubed. It can become a nightmare pretty quickly with these things. But that's what we have. All right? Now we get to play our game. Clear the fractions. So let's clear them out. Are we all comfortable with the idea that on the left side we're just going to get the numerator? Right? So we get 3x minus 5 equals, now let's see if you can do this mentally without having to actually like rewrite this here, here, and here. What would happen if I multiply this times this part? The x minus 1s would cancel. So you'd be left with an a, and you'd be left with the irreducible quadratic. So it'd look like this. A, x squared plus x plus 1. And then what would happen if I multiplied this, be careful here, times this denominator here? You just get the x minus 1 up top, wouldn't you? But it's next to what? The bx plus c, right? So it would look like this. Bx plus c right next to an x minus 1, and you would have to have those in parentheses. All right, I'll do it. All right, that's what I did. So these canceled. We had the a times that. Then here the big old quadratic cancels, and we got this thing times that. On the left side, it goes away, right? All right, sorry folks, but there is no killing off of a. Not going to happen. You can't kill off a because this is an irreducible quadratic. There is no number you can plug in here and get 0. If there was, then it would have factored up here. So we can't. So we're going to do the long method. But I'm doing the long method a lot faster than I did last time. So watch. Ax squared plus ax plus a plus bx squared minus bx plus cx minus c. So all I did here was distributed. And then here, I foiled. Now what? Group them up, right? Group them up, and then we'll factor. So 3x minus 5 equals, I've got ax squared plus bx squared plus ax minus bx plus cx plus a minus c. Make sure I didn't miss anything there. Does this feel more like algebra? All right, 3x minus 5 equals, I'm going to factor out an x squared, so I'm going to get a plus b times x squared. Then always put a plus sign. And now what's going to go in that other parentheses? A minus b plus c. And then an x on the end of that. And then finally, plus a minus c. And we have to match up with the left side now. So we're going to do exactly what we did before. It just turns out in this problem that there is a 0x squared here again. And then we get to match up the coefficients. Does anybody know how to use their calculator already to solve a system of equations? No? Okay. What are my three equations that are going to come from this?
A plus B equals 0.
A minus B plus C equals 3. And then finally, A minus C is -5. That's my system of equations. So I need to solve that system of equations. And, oh, you know what? I took this problem out of the book, didn't I? Yes, I did. See, even in the book, when they do this, it says, this identity leads to this equation. Seriously, it's crazy. They write down, you know when I cleared the fractions? Remember when I cleared the fractions? And I had 3x minus 5 equals a times x squared plus x plus 1 times bx plus c times x minus 1. When we had that before I distributed, the book has that, and then it says, oh, and this leads to this system. It doesn't even show like all the steps from that. It just goes straight from that equation to this. And then it goes from this directly to the answers. So I'm not quite sure how they expect you to do that, but they go straight to the answers. So from this, your solutions will be A is -2/3, B is 2/3, and C is 13/3. Like I said, next class, everyone bring their calculators. I'll show you how to get those, okay? But we need to write down the final answer. It's going to look kind of weird. The final answer is that this right here, its partial fraction decomposition, is a over x minus 1. A was -2/3, so watch how I write this. -2/3 over x minus 1. I know that looks strange, but that's the way I'm going to write it. The book will most likely write this, -2 over 3x minus 3. They most likely will just like bring this fraction out, drop the 3 to the bottom, and pass it through. But in a calculus class, you actually want to leave it like this, because in a calculus class, you'll actually pull that constant completely out. You just like rip it out and then do something. So just leave it. And then plus, let's see, bx, b was this, so 2/3 x plus 13/3 all over x squared plus x plus 1. And believe it or not, but in a calculus class, we're happy to see that. Very pleased. Let's do one last problem. How about that? One last one. The grand finale. And what's that saying? Go big or go home? Drum roll? No? No? Okay. We'll go real big. We'll go with the very last even problem that they have in this section. Here we go. X to the 5th minus x cubed plus x squared plus 1 over x to the 4th plus 6x squared plus 9. Use partial fraction decomposition to rewrite this. We have the higher degree this time. Good, I'm glad you caught that. I threw that in there hoping trip you up, but I couldn't do it.
What about the degrees are the same?
Okay, so what happens when we have the degree up here bigger than this one, or the same? Okay, so there's going to be two categories. If the degree up here is smaller than this one, you just do what we've been doing. But if this up here is bigger or equal to this one, then you have to do something first before you get started. And you're not going to like this. Because every time I say this, every time I ever say this word, these two words, people get all pissed off at me. Long division. Did you know I was going to say that? I don't know what it is, it gets such a bad rap. Long division. You have to do that first. Yeah, you ready? I have 30 minutes. I should be able to finish this. Okay, so look, let's see here. Long division. Now, let's do a quick reminder of long division because I think it's worth seeing. If you have like 15 over 4, right? And you're asked to divide that. You put the 15 inside, you put 4 out here. And your goal is to try and get as close to this without going over as possible, right? I know this seems like I'm not insulting your intelligence here, but let's think about it. 4 times what gives me 15 without going over? Let's see, 3? Right, so I put a 3 up here. Then I do 3 times 4, right? And that gives me 12, and I put 12 down here. And then what do I do? Very important step. I subtract that. So I subtract, and then I get 3. And then I ask myself, can I get 4 to go into 3 without going over? And I say no, right? So then we put, what here? R3. So that's like 2nd grade, 3rd grade, 2nd grade? I don't remember. Right? R, that little cute little R. My daughter's doing that. She's in 3rd grade. Okay, so we don't do that. What we did instead, we moved on, we said something like, that's really 3 3/4. So you put like the remainder over the divisor. But even that is not even good notation. Because what does 3 3/4 really mean? People often don't understand what 3 3/4 really means. 3 3/4 means 3 plus 3/4. That's what it really means. That's what it means. So when we do our long division, we write our answer. When we get our remainder, we always say take the remainder and put it over the divisor and add it. That's what we're about to do. All right. So this is just a recap of old school division. Now, let's do ours. Ours is much prettier. Okay, so we put inside the long division box, we put the numerator, don't we? And we have to be very careful that we put it in descending order, highest power of x down, and that we account for any gaps that we have. So we have no x to, we put 0x to the 4th here because we have no x to the 4th here. Then we put minus x cubed, and then we put plus x squared, and then we put plus 1? Nope, plus 0x, and then plus 1. Why do we put those zeros in there again? I forgot. Placeholders. Those are just to give ourselves positions to place things later. Okay, on the outside of the division box goes the divisor. That needs to be in descending order also, but you do not have to put zeros in for this placeholders there. And now we play our game. We have lots of games, don't we, that we like playing? All right, so we kind of say like we did with that division problem. We say, can I get x to the 4th? We ignore all this. We say, can I get x to the 4th to go into x to the 5th? Like what would I have to multiply x to the 4th by to get that? X, just an x, right? So I put x up here. Now some teachers are real particular about put your x on top of your x, but it really doesn't matter. Put it anywhere up here, right? I'm just going to put it up here. And then, just like we did with the, was it 15 over 4? Is that what I did a second ago? We did 3 here, then we multiplied, right? We did 3 times 4? That's what we're going to do now. We're going to do x times that. That means the x has to go here, and here, and here. It's like distributing an x through this. So what would happen when I do x to this? X to the 5th, and then x to this one. Plus 6x cubed, so I line it up. Here are my cubes, so plus 6x cubed. And then x times 9 is 9x, so here's my x's. I put plus 9x. So that's what we did here. We did 3 times 4 is 12, and then we came through and subtracted. That's going to change the signs of everything I have here. So we come in with our little division, or the little subtraction bar, and we change signs. And I think the only way to really do it is just get like a really exaggerated. I like to exaggerate what I'm doing here. So I'm subtracting those instead of adding. So let's start doing this. X to the 5th, take away x to the 5th, nothing. Nothing and nothing is nothing. Negative x cubed, take away 6x cubed is negative 7x cubed. And then, don't forget this one, x squared and nothing is just going to give you your x squared. And then nothing, take away 9x is minus 9x. And then 1, take away nothing is 1. That all right? Now we do it again. What do we have to multiply x to the 4th by to get negative 7x cubed? Well, we stop at this point because the power out here is bigger than the power here, isn't it? So that's kind of like me going, all right, 3, and then 4 doesn't go in there, so I put plus the remainder over the divisor. That's what I'm supposed to do here. So I need to do that here. I'm going to put plus the remainder. Yes, this is your remainder. Negative 7x cubed plus x squared minus 9x plus 1 over, my goodness, I submit. What is that? Somebody's more enthusiastic than I am.
We can't have that.
Yes, that is it. Okay, well, let's come back over to this. What we have said is that if you divide this by this, right, you get that expression up there. So I'm now going to rewrite this. This is equal to x plus negative 7x cubed plus x squared minus 9x plus 1 over x to the 4th plus 6x squared plus 9. Wow. Okay. So thinking big picture still, in a Calculus 2 class, we are very unhappy seeing this. We are much happier seeing that this can be rewritten with this becoming just an x here, because that's going to be super easy for us to work with. But we still have this ugly thing, right? But notice on this ugly thing that we have now, the degree of the top is now smaller than the degree of the bottom. So I get to do partial fraction decomposition on this now. So all of that work we just did was just to get the power on top here to be smaller than the power on the bottom here. But we also picked up an x out front. Don't forget about that x we picked up. All right. So I'm really, that x, just don't forget it's there. I'm working with this right now. And we get to do what now? Factor out the bottom, if you can. Can the bottom factor? Yes? It's kind of like a quadratic, isn't it? Yeah, I think it will work. If you use enough juju, is that what you said? This is x squared plus 3 squared, I believe. I'm seeing some squinting. Doesn't this kind of look like u squared plus 6u plus 9? If we make a substitution, u is x squared. Everywhere we see x squared, replace it with u. So this is actually x squared squared. X squared squared? Right? So this this substitution should turn into this. And then this is u plus 3 times u plus 3. And then u is actually x squared. So this is x squared plus 3 times x squared plus 3. So that's x squared plus 3 squared. Is this exhausting you a little bit today? This is a lot, huh? Like I've probably said this before, and I apologize if I have, but I'm just the messenger, okay? I'm just the messenger. I'm here to deliver the message. The message is, this is partial fraction decomposition. All right, what are we looking at over here? That cannot factor anymore. X squared plus 3 is not a difference of squares. If it was a difference there, we could break it down more, but it's not. So this right here, x squared plus 3 is a irreducible quadratic, right? But it's repeated. Irreducible quadratic repeated. So that means this is going to turn into, let's see if y'all are picking up on this. What am I going to have over here? X squared plus 3. What's on top? A? Just A? This is quadratic, right? You need linear up here. AX plus B. Okay, good. Now, am I done? No, I need to do what? Plus another, this time x squared plus 3 squared, and what goes on top of that? Another linear expression. Right? And I can stop now because I've gone up to the highest power. If this had been 3, we would need another one cubed. What's next? Clear the fractions. Clear the fractions. So I'm multiplying both sides by this, right? By this. Maybe I'll slap it in here. I'm doing x squared plus 3 squared here. I'm doing x squared plus 3 squared here. I'm doing x squared plus 3 squared there. So I'm doing that on each one. On the left side, I get this beautiful cubic polynomial expression. I don't know, just something about that negative 7x cubed. It just doesn't look pretty to me. What about this? We get one of these to cancel, right? One of those. So you'll have the ax plus b that was there, and then you'll still have an x squared plus 3. Over here, fortunately for us, they both cancel, both factors. So all you're left with is the cx plus d. We're so close. What would I do next? Expand it out, right? Expand it out, match up coefficients, and then do a calculator to solve it. Let's go ahead and expand the coefficients out. Let me just, so we have it, all right? All right, so I have to do like a FOIL here. So I get ax squared plus 3ax plus cubed. Thank you. Yes, that's, thank you. Ax cubed, and then plus 3ax plus bx squared. That would have been a major problem. Plus 3b. And then plus cx plus d. Fortunately, on those we don't have to do anything. We're a couple of lines away here from being done. Why don't you, right now, just set up the systems of equations? You set them up, and I'm going to use my calculator to solve it real quick so that we have an answer. So we're going to have A. This actually might be a pretty easy system to solve. All right, I think I got it. All right, good. They're integer answers, which makes me think I got it. Okay, does anyone have the system of equations? Want to tell me what it is?
A equals negative 7.
A equals -7. Okay.
B equals 1.
B equals 1.
3A plus 3B plus C equals negative.
Wait, 3A plus C equals -1. Okay, yep. And then, was it like 3B plus D is 1. Okay, so those are your equations. So we already had 2 of the answers just by looking. Oh, -9. Yeah, -9 here. There we go. Okay, so the answers are, you can tell by looking what A and B are. -7, B is 1, C is 12, and D is -2. So you all ready for the final answer? Our final answer is that this right here equals, do not forget the x we had. Remember the x from the long division? X plus, then it was ax plus b over x squared plus 3. So ax plus b over x squared plus 3. And then it was cx plus d over x squared plus 3 squared. There it is. Remember the first problem I did when I said, hey, this is not what we're going to do? Kind of wish that's the direction we were going, huh? It's a lot harder coming backwards with this. Can you appreciate how much harder it is to go backwards? Yes? So in Calculus 1, you actually learn about something called the derivative. I know a lot of you have to take Calculus 1. Think of Calculus 1 as the problem I put on the board, how we went that direction, how it was pretty easy. And then think of Calculus 2 as going the other direction. So that's exactly what it is. It's the reverse operation. And it's just like this. It's much more complicated. All right. So in the last 10 minutes, what I'd like to do is, y'all were requesting a quiz, weren't you? Were you requesting a quiz last time? That wasn't me, man. I think I think we should do a quiz, not today, but let's do a quiz next class for sure. All right? I'm thinking it'll come from like vector, polar, and then maybe something like the first problem I did here, not the forward direction, but the reverse direction, where you could kill off, where you could like do little let x, and just get A and B right away. I think if you do work on the homework for that section. Oh, homework. I should tell you what I want you to do here. For homework, do page 908. And let's do 13. I think 13 through 29 odd is a decent set of problems. Your homework will be something like number 13, 14, 17, 18. I'm just looking at these. 13, 14, 17, 18. All of those would be like what I would ask on a quiz. 13, 14, 17, 18. All right. So I was going to say in the last few minutes, I was considering like giving you like the formal steps on how to do partial fractions. It's up to you. If you feel like you've got it, then I don't want to make it worse, but I'm happy to put up like formal process. With that enthusiastic reply, what I will do is, how about this? Beginning of next class, I'll bring in my notes from Cal 2, where what I show them, I say, hey, remember partial fractions? And I show them the steps. I'll show that to you, and that way you can see, and then we'll move on. So next class, next time we meet, we're not going to do this anymore. We're going to move on to the next thing. And the next thing, I'm not sure what it's going to be. It's either going to be parabolas or ellipses, or I don't know, maybe something with parabolas or ellipses. Yeah. All right, 3 classes to go. How much information can I cram down your throat in 3 classes?
Will we ever have to do anything with that, like X?
Yes. I mean, do we have to here? Not here. No, you just make sure you include it as part of your answer.